talking about pure physical mathematics and the sequence series in the third chapter. Okay, let's start.
So today we'll talk about the method of differences and a little bit about partial fractions. So let's have this question. How would you find the sum of this? Now, inputting values into this one by one and finding the terms, you can't really find any relations because both of the unknowns are on the denominator, and we don't like unknowns in the denominator.
Yep.
Or more so, we like them separated.
Or
so
simplified.
How do we go about in separating these kind of functions? Well, we can look at the formulas over here. What the fuck? We cannot look at the formulas over there. To put it simply, if you have, let's say,
so a quick cut-in is
over something
try not to
b
brute
plus
force
c
these. We try to make them simpler
equal
so
to
they can be
d
solved
over b.
easily.
So you can see that the denominator is separated. B goes to B and C goes to C. And then you'll find some extra coefficients in the numerator rather than A.
Yep.
So we can write the expression as 1 over r plus 1 equals some coefficient A over r plus some coefficient of B over r plus 1. Now, through cross multiplication, you will know that BR plus A times r plus 1 equal 1. Let's expand the brackets. BR plus AR plus 1 equals, plus A equals 1. And collect the terms B and A.
Yep.
Now, since there is no variables on the right-hand side, that means that any variable of r on the left-hand side, the coefficients must equal 0. So in this case, b plus a must equal to 0, or b equals to negative a. Now, if this part is 0, that means it's gone, and now we're just left with a equals 1. From b equals negative a, we can infer b is negative 1. Now we can go back to the equation, and we can say 1 over r times r plus 1 is 1 over r, and b is minus 1. It would be minus 1 over r plus 1.
Yes.
So we can rewrite the expression.
Oh, hell. That was loud.
Yeah. Don't worry, that's just my dog. Equals the sum
1 over r, take away 1 over r plus 1.
Now, because we know that the summation, you can apply it over, you can like distribute it. So we
1 over 1.
You don't need to distribute it, actually.
Just try out the first.
So this is a much simpler equation to look at, and now we can try to substitute some values inside of it.
Yep.
So let's look at the first two terms. It will be 1 minus 1 over minus 1 over 2. Then r is 2, so plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4 plus 1 over 4 ...
Yep.
And all the way to the end, where it would be 1 over n plus 1 over n minus 1 over n plus 1.
Yep.
Yeah.
Yeah.
Previous would be minus 1 over n. So I write it this way because what you can see, look at this. There's minus a half and plus a half, and then there will be no more. That means these cancel out. similarly to 1/3, to 1/4, all the way to 1 over n. So now all that we are left with is just 1 over 1 minus 1 over n plus 1, where we can just simply write is 1 minus 1 over n plus 1.
Yep.
And that is the general solution.
Easy. Now we look at some more examples of partial fractions, because they're really important later on when you see really big fractions. Over here on the very top right, which is written in very neatly handwriting. And Raymond, I'm following you, so you better speed up. So essentially they look really complicated, but then what it really means is, for this one, any equation like fx over a x equation multiplied by another linear x will give a over x, the first one, plus b over the other linear equation of x. That's pretty simple for the first one. And the next one, a linear equation over a quadratic equation. Basically what you do is you take the quadratic and then you have a linear, and they still have non-variable numerators. So all their numerators for the first two cases should not include any variable. And then for the last special one, where you have a cubic sequence as the denominator, you have a quadratic as the numerator, you will end up with a linear denominator and a constant numerator with a quadratic denominator and a linear numerator. And that's basically it. Really easy. You should know these.
Okay, can you expand this though? Considering fx.
No, if you expand it, it's gonna be worse. If you expand it, it's gonna be worse. Because multiplication is the only one you can separate. If the denominator is addition, you cannot separate them.
Yeah. Oh, you can, because like...
Okay, then you'll have to get it into denominator form. You'll have to get it into like bracket forms. I mean, just know these. They won't be very necessary for the A-level exams for the first two chapters for Pure 1. So yeah, and these are the only fields you have to know. And good luck. You have anything to add on?
I mean, I wonder, considering fx over gx times hx, which each order is in terms of, let's say, n1, n2, and n3,
Yeah.
what would be the partial fraction of, like, let's say, big F over gx?
First the condition has to be they're all in proper fraction form, and you have to break it out for the non-proper elements.
Let's say theta x.
Okay, so basically...
And what would be the order of these?
So, Raymond, the order is linear, non-linear on top, quadratic, linear, and then a cubic, and then a quadratic. You know, the top is not always. For squared, denominator is different, because squared denominator is considered the same multiplied by the same, and that is really, really complicated later on. Okay, we're not going to talk about the cubic ones with the bottom, because they are like a torture.
Because right now it's...
Right now it's that is much beyond. Wait, that is much beyond. I'm gonna stop.